I hope you are all having an absolutely wonderful day. As always, if you like this video, hit the like button. If you want to comment, please do so. Or if you want to ask any questions, feel free to put something in the comment section. If you want to share the video, please do. And if you'd like to subscribe, that would be great. That would help with future tech videos coming your way. Now, let's get on with the video. In this presentation, we're going to be staying with the BGP attributes, and in this particular video, we're going to be looking at the origin attribute. So let's have a look at the presentation agenda, what we're going to have a look at. We're going to do a quick recap of the BGP attributes. We're going to have a look at what the origin attribute is, the types of origin values, the role of origin in the path selection, a configuration example on Juniper, verification and troubleshooting, and we'll also pop in there a summary. So let's start with a quick recap of BGP attributes. So it's just going to be a quick overview. So BGP, as we know, uses path attributes to select the best path. Categories of BGP attributes are the well-known mandatory. We've already gone through this, but I'm just doing a very quick recap. Must be recognized by all BGP implementations, and examples of the mandatory are origin, AS path, next hop. Well-known discretionary, they're optional, but they're widely recognized, and it's one that we've gone through already. So an example would be the local preference. Optional transitive, they're passed across AS boundaries. So an example there is community, and optional non-transitive are not passed to other BGP speakers. In other words, the example here is the multi-exit discriminators or the MEDs. So here we're going to focus on the origin attribute, which as we can see from above is the well-known mandatory attribute. So what is the origin attribute? We've already gone over it, so again, this is just a quick recap. So the definition, it specifies how a route was introduced into BGP. The purpose, it indicates the origin of the route for the path selection, and it helps routers make informed routing decisions. So what are the types of origin values? We've gone through it, but we're going to do it again. So we've got the IGP, which would be signified by the I. So the route originated within the local AS via a network statement, and it's most preferred. We've got EGP, which is signified by an E in the routing tables, and it's a route learned from an exterior gateway protocol deprecated. And we've got an incomplete, which would show as a question mark or blank. And that's a route redistributed into BGP from another routing protocol. An example again, OSPF, and it is the least preferred. So what's the role of origin in path selection? Well, let's have a look at the path selection order in BGP. We've gone through this as well, but we're going to quickly do a recap. So we've got the highest local preference. We've got then the shortest AS path. Now, again, if it's Cisco, above highest local preference will be wait, but we're not going into that because this is Juniper. So after the shortest AS path, we've got the lowest origin value, which is what we're looking at. So as it states here, IGP is preferred over EGP, which is preferred over incomplete. We've then got the lowest multi-exit discriminators, eBGP over iBGP. In other words, the selection it makes is if the highest local pref is the same, it goes to the second, the shortest AS. If that's the same, it goes to the lowest origin. If that's the same, it goes to the lowest MED. If that's the same, it goes to eBGP over iBGP. If that's the same, it goes to the closest IGP neighbor. If that's the same, it's the lowest router ID. So origin, as we can see from this, is considered after AS path length, but it's considered before the multi-exit discriminators. So here's a Juniper configuration example. So in the example that we're going to give you, we'll use the IGP, redistributing OSPF routes into BGP, ensuring the correct origin. So firstly, we have to define, as we did with the local preference, a redistribution policy, so it all works on policies. Okay, so we do a set policy options, policy statement, redist, OSPF. Now that's just a name. You can call it whatever you want. term 1 from protocol OSPF. We then do the accept. We then have to apply that redistribution policy to our BGP group, and we do that via set protocols BGP group, your group name, in this case eBGP, and we export the redist OSPF, which is the name of the policy from the first step that we noted above. Then we can verify the origin attribute by doing the show route advertising protocol BGP. So let's have a look at an advanced configuration. They're still simple configurations, but this would be a slightly advanced one on the previous config. So here we're going to modify the origin attribute for specific routes. So first we create the policy again to set the origin. So we do set policy options, policy statement. This time we've called it set origin. Term 1 from route filter, and I've just made up this network. It will be the networks that you want to set. So I've just made up 192.168.1.0/24, match it exactly with the exact statement at the end. Then we set the policy options, policy statement, set origin, term 1, then origin incomplete, which if you note from the previous slide, that's what it would come up as, a question mark. Now we apply the policy to the BGP group, and we do a set protocols BGP group, and again it's the name of the group, eBGP export set origin. Okay, so the group name is eBGP, and we're exporting the set origin policy that we noted above. And lastly, we can verify with the following command: show route 192.168.1.0 extensive. Okay, and that will show the origin itself within that. Okay, now verification and troubleshooting. So we can verify the origin values with the following: show route protocol BGP extensive. We can check the route advertisement, show route advertising protocol BGP. And we can troubleshoot policy issues by doing show configuration policy options. And we can review the BGP session status, so we can have a look at the show BGP neighbor. Now what we're going to do is we're going to go to our live configuration as per the local preference video and see the origin in action. So here we are at the live demonstration screens. So what I've done is I've added a router in, and I've called it OSPF1, and I've connected it to our AS. If we do a very quick show configuration and we do it as a display set, you can see the configuration then. I've already set GE004, which is the address that connects to our AS, and I've set up the OSPF area. Okay, so we have G004 in there, and we have the loopback interface in there. The loopback is 100/32, and we've added a router ID, a RID, for the OSPF. So if we go to our AS and we have a look at the show configuration, and we again do it as a display set, you'll notice that we have GE004, which is the connection to OSPF1, and we have OSPF set up with that interface in it so that it advertises that address. So the first thing we're going to do is we'll have a quick look at the show route, and in here you'll notice that we have the 100/100/100/32 address via GE004 as stated. If we go to the destination, which is the other end, and we do a show route, we have a look in there and we do not see the 100/100/100/100 address. So all the configuration work is going to be completed on our AS. So the first thing we're going to need to do is we're going to set our policy options and policy statement and create or inject the OSPF routes into BGP. So let's go ahead and do that. So we'll edit and we'll do a set policy options policy statement, and we're going to call this one redist-ospf, and we'll give it a term 1, and it's from protocol OSPF. That's what we want it from. And then we're going to accept that, so we can use the up arrow. We do term 1, then accept. So we do a then accept. We can now commit this to the running configuration. So we're going to set this to go to ISP1. So what we're going to do is we are going to redistribute that address, the 100.100.100.100/32 network, or address if you like, into BGP. So we're going to do a set protocols BGP, and the group is going to be 2-ISP1, and we're going to export the redist OSPF, and we're going to commit this. Okay, so that is now committed into the BGP group required to ISP1. So if we go to ISP1 now and we do a show route, we see that we have 100.100.100.100 advertised via BGP. Now, the important thing here is to note is that on this particular Junos version, we don't see the origin no matter what command we put in. So we have to look at the AS path and then the letter that comes after it. And it's an I, which stands for IGP, which means it has been learnt via OSPF. If we go to the destination and we now do a show route, we will see that we have 100.100.100.100, and again IGP learnt via BGP. Question is now, which is regarding the origin, where we want to see what's preferred, is we need to go back to our AS and we're going to create a secondary policy, and we're going to call it set origin. This is where we do the slight advanced configuration and we change the origin itself. So if we do a set policy options policy statement, and we'll call this one set origin, again term 1, and from protocol OSPF. We then do, under term 1 still, we're going to do our route filter. So we do a from route filter, and the route filter is going to be 100.100.100.100/32 exact. However, these would be the networks that you want to change the origin on to determine a route if the local preference is the same. So we press enter, and now we're going to do term 1 again, but now we're going to do then origin incomplete, then origin incomplete, and then we're going to do an accept. So we do an accept. Now, before we actually place this policy within the BGP group, what we're going to do is we'll set the original policy into ISP2 as well. So we'll take this command and we'll go to there, and we're going to put it into ISP2, and we're going to export this, the redistribution of OSPF, and we'll commit that. So we now have it going to ISP1 and ISP2. So if we do a show route here now, we should also have the 100.100, and we do. So we have it as an I. Now, they are both equal at the moment, so it would have gone further down the attributes list to have made a decision where destination sees it from. So if we do a show route again, it probably should not have changed, and it hasn't. So it sees it via this interface with the local preference and still with the I. We'll show you further on how it made that decision. So now we go back to our AS and we have a look at this secondary policy we made. And what we're going to do is we're going to remove the filter from ISP1 so that you see what happens via ISP2. So now we do set protocols BGP, and the group is going to be to ISP2, and we're going to export the set origin, and we're going to commit this. So having a look at the route on ISP2, we'll note it still has the I there, but if we go back to our AS, the reason for that is quite simple. If we do a run show configuration and we do it as a display set, we'll have a look and we will notice that we still have the redist OSPF. So if we remove that and we just leave the set origin in there, so we're going to remove this one. So let's remove that and we'll commit this. And then we'll go back to ISP2 and we'll have a look at what we have in there. So let's have a look at the show route on ISP2 now. Now you'll notice that instead of the one that we had before, we now have the question mark because we asked it to become incomplete by changing the origin. So the question is, on the destination, what do we see there? So the show route, you'll note that we still see it coming in under the IGP side because IGP is preferred over incomplete. So let's go back to our AS, and what we'll do is we will remove the redistribute OSPF from there. So let's delete the redistribute OSPF from the ISP1 group, and we'll commit this. And what we should see now under destination is if we have a look at the show route again, here we've got it coming in under GE004.0 and we see it as an I, which is the IGP. Now we see it as a question mark for incomplete, and we see it coming in via ISP2. We could do the same the other way round, but what we're proving is we're proving that it will take the path of IGP over an incomplete because it's the preferred route. So if we go back to our AS and we put that command back in again on ISP1 group, let's put that back in and we do a commit. Now let's go back to destination and recheck the route again. Now we have the route as I, as the primary because it's got the star next to it. So it's the preferred. You'll note that we do have a secondary route, but it is the question mark. And this is how we can control routing by changing the origin. So let's go back to the presentation and we'll just summarize that up. So let's do a quick summary of the origin attribute. So as we've seen, the origin attribute is another powerful tool in the BGP path selection process. The origin attribute is a well-known mandatory BGP attribute. IGP, lowercase I or uppercase I after the AS path value in the output, dependent on your Junos version, is always preferred over an incomplete, which is a question mark, or an unknown, which will show up as blank. The origin attribute is considered in the list of attributes that BGP utilizes to make its path selection process. It's considered after AS path, but before the MEDs, which are the multi-exit discriminators. So if you like this video, then please subscribe, as you don't want to be missing future tech videos coming your way. Have a lovely day, enjoy yourselves, and thank you very much for watching.